In this next video, I'm going to talk about some Azure non-SQL based database solutions as well as a Redis cache. A couple of things I want to walk you through is DocumentDB, MongoDB, and MySQL. Very popular database solutions available in Azure and mainly coming from an open source environment. Then after talking about databases, I also want to share a couple of words about Redis cache. Now let me start with giving you an overview of DocumentDB. DocumentDB is a fully managed non-SQL document-based database service which provides an optimized high-performance, backed by write-enabled SSD storage database platform. It natively supports JSON and JavaScript. Indexing is automatically managed about all documents inside the database. It allows for global data replication, and it also provides an enterprise-grade SLA. A quick overview of some of the DocumentDB features we have available in Azure is the following list. First of all, it provides rich SQL-alike queries over a schema-free JSON storage. Server-side execution-defined application JavaScript as stored procedures and triggers is also provided. This basically means it's a pretty powerful database format. JavaScript language is integrated for multi-transactions, and it's based on tunable consistency levels for optimal application performance. And the last thing I can add here is that it provides standard JSON-based storage with RESTful HTTP interfaces. Some other features, as you can see from the screenshot, is natively browsing through the database, performing scale-up, scale-down settings, viewing documents through the Document Explorer, executing queries by the Query Explorer, and performing script analysis using Script Explorer. Then from an architectural view, the database structure looks as follows. It starts with a DocumentDB account from which you can create one or multiple databases. On the database level, you create users, providing them access by storing and configuring permissions. Within a database, you're going to build up collections, where each collection stores procedures, triggers, and end-user defined functions. Within a database collection, you can store your documents, which basically are JSON files. Now, DocumentDB was just one example of a non-SQL Azure database solution that we have available. Another example is MongoDB, which is basically the same document database type. Supporting MongoDB, it's available from multiple vendors, and there's even a Microsoft version available at the time of creating this course in a preview format. A third very popular database format is MySQL, which is again available as a standalone database, or deploying it in combination with web applications that I covered in the previous module. It's the most common version provided by ClearDB, which is the vendor of MySQL. Support for clustered MySQL architecture is provided in Azure, and there are several marketplace solutions also available, allowing you to easily build out solutions on top of MySQL. So this was a little introduction on different NoSQL-based databases available in Azure, where another interesting thing about databases that I want to talk about is Redis cache. Redis by itself is an open source and key value caching mechanism, also referred to as data structure server, and this is the definition from Redis cache itself. Redis provides the following characteristics. First of all, replication. Its architecture is based on a master-slave application or replication, which allows Redis servers to be exact copies of each other, and it's using an async replication mechanism to make sure the master-slave is always up to date. Next one is that it provides LUA scripting, where LUA is the powerful scripting language for Redis. And the LRU eviction is one of the methods allowing for proper data cleanups within the caching store. When deploying Redis cache in Azure, there are three versions available: a basic one, standard one, and premium one, where the basic one exists as a single node, giving you a maximum of 53 gigs of cache. The standard and premium is based on a 2-node replication cluster, where the standard gives you a maximum scale of 53 gigs again, spread up in multiple sizes, and the premium version gives you again a 2-node replica and shared with maximum of 530 gigs in total. Now this was a short introduction on using non-SQL database solutions and Redis cache, where I would quickly want to show you some stuff from within the portal. So from within the Azure portal, I can browse through my databases and opening up all the databases we have available. And then here there's the first one, non-SQL DocumentDB. Now before deploying this one, let me quickly show you some other formats we have available from the marketplace. Here you can find Redis cache that I talked about in the introduction. And even besides your already mentioned databases, Oracle for example, another pretty important and popular one, ArangoDB, CouchDB, EloQueraDB, being the list is getting longer by the day, so just keep in mind that it's not only Windows or Microsoft SQL Server that's being supported in Azure, which was mainly the key message for this specific topic. Now going back to my non-SQL, I'm going to start by creating a DocumentDB database. So it asks for an account ID, which needs to be unique. Then here I can specify which API I'm going to use, the native DocumentDB or MongoDB, creating a new resource group, you're already familiar with this one, and your specific Azure region. It's validating the settings, and in just a few minutes it will create a database structure. So let me add another example here. Redis cache can be deployed in the exact same way, providing a unique DNS name, where the data and backend is always related to redis.cache.windows.net, providing a new resource group or again connecting to an existing one. Also having to specify the pricing. Here I'm going to use standard as a default. I'm going to take it down to the basic one just for deploying and then forcing the creation. I'll give it a couple of seconds before the databases are actually being deployed. I already have my resource group available and my DocumentDB is also there, but it's still in creation process. Now after only a few seconds and refreshing my screen, my DocumentDB database has been created successfully, where I can continue with the next level in the hierarchy, creating a new collection. So from here I provide again a unique name, selecting the pricing tier, defining if it's a single or partitioned one, and then creating the database. As you can see here in this geographical map, my database is currently located in West US, since that was the Azure region I selected. If I would opt in for a partitioned one, then I could decide and split it up, replicating the database content between multiple Azure regions. From here, I can also move my database between subscriptions and even between resource groups. Now this was a really quick introduction on how to create DocumentDB and how to create a collection within your DocumentDB database. Which brings me to the end of this video. I'm hoping to see you again in the next one, where I'm going to cover Azure IoT solutions and components.